You should be good now. Here's at our virtual chapter meetings for the rest of the month. Women in Technology is doing Reporting Services 2016, Data Architecture on July 27th. Make sure you check them out. Register on the SQL Pass main site. You'll receive emails for their upcoming meetings and upcoming announcements. Upcoming SQL Saturdays. Columbus is this Saturday. The following Saturday is Sacramento and Sioux Falls, and so on. Those are for the U.S. side. 23rd, you have Manchester, England, Gothenburg, Bangladesh. They're all coming up. So PASS does not exist without volunteers. If you are interested in volunteering for PASS to either help with a virtual chapter or for a local SQL Saturday event, visit your site volunteers.sqlpass.org. And lastly, stay involved. If you're interested in doing more with PASS, or if you're interested in more events, sign up and check out the site here. So that's it for me. Alejandro, are you ready to go?
I'm ready.
Okay. Let me get it ready for you here. Oh my goodness.
All right. So welcome to this UFC 1433 In Memory Tables 2014 versus 2016. My name is Alejandro Cordero, and I will be presenting for you today. I'm a regular blogger at SQLturbo.com. I will be posting demos and the scripts that we will be showing today at SQLturbo.com in case you are interested to get them there. I'm also the lead database consultant at Python Company. I'm Scrum Master Certified and Microsoft MCSA. And also you will see at the bottom of the screen my email, alejandro@turbo.com, in case you want to send over any questions after the presentation. And for today's agenda, we will be talking about the in-memory tables. Since we are going to compare 2014 versus 2016, we are going to start first with some background information on what the in-memory tables are. Then we are going to jump into features back into SQL 2014 and the limitations. And we are going to see a short demo on how you used to work with those on that previous version. And then we are going to move to the new features of the SQL Server 2016. The limitation that we still have, and we are going to close with a demo and some conclusions. Okay, so what are in-memory tables? So back then in SQL Server 2014, there was a project called Hackathon, and basically what Microsoft intended was to create table structures that will reside in memory, basically. And the promise back then was that by using in-memory tables, you were going to experience a performance boost of up to 30x or 30 times faster than a normal table, potentially. These tables and the indexes related to these tables were going to reside in memory. And what happened is that since these structures were not going to reside in disk space anymore, then the fundamental structures of data pages are no longer existing for this new feature. Basically, everything is going to be in memory, and instead of single data pages, you are going to have complete entire single rows. These rows are going to be accessed by the SQL Server engine through a set of pointers. So basically, instead of having small data pages in a disk, accessed through indexes, now we're going to have pointers to memory spaces. And because of this, we are not going to have latch or logs in these in-memory tables. And what happens is that, latch and locking mechanisms are created for basically maintaining consistency of the data inside the tables. So for in-memory tables, the consistency is going to be accomplished through row versioning, and conflict detection, basically. And what this means is that every time you insert, delete, update the information, instead of, let's say you are updating just one column, instead of just updating that single column, what it is going to do is that it is going to make a duplicate of that row in memory. So you are going to end up with duplicate information. And then you are going to have a garbage collector that is going to take all these versions or outdated versions, and it's going to delete them. And this is the way an in-memory table is going to work. You are always going to have a pointer to a complete row of information. Instead of having indexes covering, for instance, just one column or two columns, you are always going to have the full row to work with. And this is very important, and we are going to see why in the next few slides. So back then in 2014, there were introduced, along with in-memory tables, the natively compiled store procedures. And the idea of natively compiled store procedures is that you are going to code everything inside that type of store procedure, and then you are going to store it. But as soon as you save that store procedure, SQL Server is going to create a set of DLL binaries and a fixed execution plan, basically, available to SQL Server. This means that next time you execute this store procedure, the execution plan is going to be available, and the execution is going to be much, much faster. And so this is one of the ways that you will try to use in-memory tables, by creating a natively compiled store procedure, and inside this store procedure you are going to call or use your in-memory tables. And this is the most recommended way, because it's going to provide you with the best performance. And the idea of using this type of store procedures is when you need to optimize performance of critical business logics, that you actually need to have a really good performance or throughput. The thing about natively compiled store procedures is that since it basically creates a DLL with fixed set of information for SQL Server to use this faster, basically Microsoft had to rebuild most of the functions and the T-SQL features. And so by 2014 we had a bunch of limitations, like not all the built-in functions were available, like some math or string functions were not there. So you basically had to only do certain type of business logic inside of this type of natively compiled store procedures. Another limitation is that inside a natively compiled store procedure, you can only join in-memory tables. You cannot do like join an in-memory table with a regular normal table that is on disk inside a natively compiled store procedure. So even though this is going to provide you with the best performance, it does have some limitations. And in 2014, when you didn't want to use this type of store procedure, you could just use the access through ad-hoc queries. And what I mean by ad-hoc queries is just a regular query when you open SQL Server Management Studio and just fire up some insert statements or query statements against your table. This is mainly for reporting style operations, or when you're building a T-SQL logic where the options needed are not available inside a natively compiled store procedure. Like you mentioned, if you're using a function that is not available, then you will need to use necessarily access through ad-hoc queries. The downside of using this ad-hoc access is to have less performance improvement compared to the natively compiled store procedures. Now, keep in mind that if you're using in-memory tables, either way, if you use ad hoc or natively compiled stored procedures, you're still going to have a good performance or better performance compared to a normal table. It's just that using natively compiled stored procedures provides you with the best performance options. And so when Microsoft introduced in-memory tables to the 2014 version, well, naturally, if you have a table structure, you are going to ask about indexes, right? Like you need to index your data so it's faster, so you are able to query your information in a better way. And so this happened. We not only got in-memory tables, but we also got in-memory indexes. And the cool thing about these memory indexes is that their structure is very different to the normal indexes that we are used to with normal tables. The first thing that is very cool is that you won't see any fragmentation with this type of indexes. The other difference is that they won't contain any data. The disk-based indexes, if you use a cluster index, for instance, it is going to contain your actual data of your table. In this case, these indexes are not going to contain any data. And why is that? Well, basically, since we have pointers to memory spaces, the indexes is going to be conformed by a set of pointers as well. So indexes is mainly a group of pointers, grouping a memory space, basically. So they are not containing data, just a set of pointers. Because of this, we are not going to have included columns in the indexes. Like I mentioned a few slides ago, we are going to have full versions of the rows in memory. And since every time you are handling a full row, you're not able to just specify, okay, index just one column or two columns or three columns. You are going to index the whole thing at the same time. But instead of indexing the whole, but you will have index the entire set of columns of your table. This is what I mean. And basically all indexes are covering, the full row is returned, and then because of this, you're not going to have lookups. Those are like the fundamental differences between in-memory indexes and regular disk-based indexes. Now, we also got a couple of types of in-memory indexes. The first one is the non-cluster in-memory index. And the non-cluster in-memory indexes, these are good for range lookups, order scans, performing SIGs against your data. And then you're going to have another type of index which is called the hash in-memory index. And basically with this hash index, you are going to try to perform only point lookups. And by point lookups, what I mean by this is something like an equals operator. When you say something like, give me all the information from X table where the category equals, certain value, certain string. When you're using that equal operator is when these hash indexes are much faster than a non-cluster one. The thing about the hash indexes is that they come with a bucket count. When you define your index, you need to specify an estimate of how many rows you think that index is going to contain, and that's what we call the bucket count. So if you are indexing your table and you estimate that you're going to have 1,000,000 rows, then that's going to be your bucket count, 1,000,000. And what it is going to do is that you're going to have 1,000,000 pointers already allocated for the information. So every time you get a new row, a new pointer is used for that row. And so as you start to grow your table, as you start to reach your 1,000,000 rows, you're going to completely use all those pointers. And so what happens if you ever reach to that maximum bucket count? Well, what's going to happen is that instead of using one pointer for a single memory space, the index is going to start sharing those pointers. So it's going to start and use one pointer for 2 or 3 rows, and this can potentially cause a performance issue. So the idea is to overestimate a little bit this bucket count, and if you estimate that, I don't know, probably the first year you're going to have 1,000 rows, probably go for 2,000 if you want to estimate for 2 years, something like that. So you make sure you are not going to run out of pointers available inside your index. There's actually a sweet spot, and it actually depends on the amount of data you are handling inside your table. Because if you overestimate very highly, what it is going to do is that SQL Server is going to create a lot of pointers in memory, and in the end, these pointers are going to use a little bit of memory. So if you overestimate a lot, you are basically wasting a little bit your memory space. So the idea is to find that sweet spot where you don't set up your bucket count very high or very low. It actually will depend on the amount of rows you're generating per month, and the estimated growth for the next months to come. And here's an example of the syntax of an in-memory index. You are going to create your table, and then you will see here first we have normal column, and then right after you will see index ID hash C1 with bucket count equals 100. And then with memory optimized on, durability equals schema only. So this is an example of the syntax you will typically use for a hash index. As you can see, you create this type of indexes along with the table. You are not able, in SQL Server 2014, you are not able to create your table first, and then sometime after create an index over that table. You need to create your table, and the table needs to come already with the indexes already defined in your original table creation. As you can see in the syntax, you will see there, that small portion that it says bucket count. That's where you specify the number of rows you estimate you are going to be indexing for the next months to come. In this case, we are using 100. And then the last sentence over there that it says with memory optimized equals on. Well, this is the way you tell SQL Server that you're not using a regular index, you're using a memory optimized index or in-memory index. And then the durability is you can use this as schema only or schema and data. Basically, this means that if SQL Server is going to keep your data even though you restart your server or your instance, if you use the schema and data option, it means that the data is going to be there after a restart. If you use schema only, it probably means that you're going to lose that information. Because in the end, we are working in a memory space, which is a volatile type of storage. And then in this second example, you will see another table creation, and you will see index IDX non-cluster C1. See, the syntax is a little bit different. In this second case, you don't need to specify your bucket count. It's just a regular non-cluster index. And in the end, you do have to specify your memory optimized options for your table. So it is actually an in-memory table. So basically, this is the way you set it up in SQL Server 2014. We're just looking, generally the syntax, but we're going to see a demo in a few slides next. So we actually see how it works and the options that we have available. I got this this chart or this table from MSDN, and it's actually a quick reference when you're trying to use in-memory tables and you want to use an index over it. As you can see on the first column, we will have the operations that you are able to do over your data, and then we have 3 columns. The first one is the hash memory optimized index. The second one is the non-cluster index, and the third one is the disk-based index. And then over here you will see what type of operation is good for each of those indexes. As you can see in the third row, if you see for the hash index, the one that we are specifying the bucket count, you will see that it will be an index scan every time you do an inequality predicate. This is when you use a greater than or a less than. Every time you try to do this type of range loop, if you are using a non-cluster hash index, a memory optimized index, basically it's going to result in a full index scan. And this is important because now that we have this new type of memory structure, and if you check the execution plan, you will start to see this type of operators. And this is the way you are also able to optimize queries that are using in-memory tables. This is very important because maybe you are using the query, and even though you're using an in-memory table, you're not getting a good performance out of it. Maybe it is because the index that you have created is not the proper one for the type of query. Maybe you need to use a non-cluster index instead. Or if you are, on the other hand, if you're using an equality predicate, an equals operator, maybe you need to use a hash index, and then you're going to have even more performance out of your in-memory tables. So this is a quick reference for you to have in there. It's actually very useful for, especially for performance tuning while using in-memory tables. And so for SQL Server 2014, our limitations are basically, this is not a comprehensive list, but these actually are the most important ones. You are not able to create a trigger over in-memory table. You also have data type limitations. You're not able to create a column as an LOB. You're not going to create a table as an XML, CLR, spatial data. Those types, if you try to do that with your table, you're going to get an error message from the compiler. You're not able to define a constraint over your in-memory table. No foreign keys, no check constraints. You're not able to do schema changes. If you create your table and you forgot to add a column, you're not able to alter your table and add a new column. You will need to drop your table and recreate it. And then the same way, you're not able to add or remove an index. You need to create your table, and it needs to come with the index already created. Otherwise, you need to drop your table and recreate it all over again. So that's a very important limitation. And why I say it's very important, because, well, now that we have in-memory table, there's a new type of conversation that needs to happen when you are designing and planning your application. When you are designing your database, your database design, you not only need to set up, your table structures and your relations. Now you will need to define, okay, out of all these tables, which one of these are going to be in memory. And if they are going to be in memory, you need to strictly define and analyze it, because you will need to properly define all the columns and the data types, so you avoid in the long run, the need to, drop the table and recreate it and, and refill it with information. So this is very important when you make the decision to use in-memory tables. Don't skip on actually analyzing your business logic, because it's very important that you define those data types and those columns, so you don't need to redo your work in the long run. And then also for natively compiled store procedures, when you use this with in-memory table, you're not able to use a distinct, execute a select distinct with your tables. You can't use case operators, for conditionals. Just some basic built-in match string date functions. There are some limitations there. And now let's see SQL Server 2014 in memory in action. So what I have here is my local environment in my laptop. My default instance is a SQL Server 2014. As you can see over here, I have a bunch of databases. And then I have a second instance over here, named instance called SQL Server 2016, with the 2016 newer version. Let's see. So let's start instance. So I'm going to create a database called in memory. I'm going to define these data files and log files. This is just a regular table with a bunch of default options. Okay, so I go ahead and check my database list, and over here I already see my in-memory database. So that's our first step. Then we are going to create our tables. Memory table. What do I need to do first? Okay, so like any other table, it needs to reside inside a file group. In this case, in-memory tables need a memory optimized file group as well. So as you can see here in the first option in my screen, you will see over here, alter database in memory, add file group in memory, contains memory optimized data. So this last portion of it is what is going to convert it into a memory optimized structure. So and now I'm going to add a data file to that file group. So I'm going to run this alter in memory add file. I just define the file name. As you can see, the main difference here is that you don't need to define an extension to this file name. It's not like you have an MDF or LDF file. Basically, you're just defining a folder. Inside that folder, SQL Server is going to take care and create a bunch of structures and files and binaries and DLLs. So basically, you are defining here a folder, not a file. That's another interesting difference against normal file groups. So I just created this. And then I will try to create my table. So basically, I have this table that is called log. I will have a log ID, which is the identity, and I will have a bunch of descriptive columns over here. At the very end of this table, I will define that it is a memory optimized on. This is going to create my table as a in-memory table, and then I'm going to define this durability. I'm going to have schema and data. And like I mentioned before, when you define schema and data, it means that even though you restart your instance or you restart your server, SQL Server is going to guarantee that your data is going to remain there. If you use schema only, SQL Server is going to delete all the data after you do this type of restarts. Schema only makes sense for the type of scenarios where you're trying to use like temp tables. Maybe you used to have a regular temp table, but it had a performance issue where you can replace that temp table with an in-memory schema only type of table, and that should increase your performance. That's one scenario where you will choose to use one or the other. So if we go back a little bit over here, let's say I want to create this table and add this XML column. So I'll go ahead and try and create my table over here and execute this. See, and I already have my first error. It says the type XML is not supported with memory optimized tables. So this means that in SQL Server 2014, I'm not able to use XML data types like we mentioned before. Another interesting scenario is the collation of the columns. Like as you can see over here, I'm trying to create a column which is and I'm defining as a collation a Chinese type of collation. And then let's see what happens when in an in-memory table with this type of collation. See over here it says this data type is using a collation that has a code page other than 1252, which is not supported by in-memory tables. So with SQL Server 2014, there's a default basic collation for your strings. So this is very important if you want to use an in-memory table, but you're trying to use a specific collation for a Japanese, Chinese, or something like that. You have that type of business scenario. You need to know this. There is a restriction for SQL Server 2014. And so let me just go ahead and, I'm not going to create those type of columns. I'll just go ahead and create my table. See, now it completed successfully. I don't have, restricted data types or restricted collation types. Now I was able to create my table. So what happened here is just, I just created my table, and turns out I forgot to create my index. So now I'm going to alter my table and add the index. And over here you'll get that error. The operation alter table is not supported with memory optimized tables. And if I try to create my hash index over here, it's not going to work as well. It says hash indexes are permitted only in in-memory tables. So what happens over here is that if I go back a little bit, I will have to drop this table that I just created and add the indexes that I need as part of the table structure. So over here I will need to add my hash index and my non-cluster index. So I just drop that table and I'm going to recreate it with the indexes already in there. See, and this way I managed to create my table successfully. So I have those restrictions and I'm not able to alter the table afterwards. Just to run some examples, I'm going to create a log normal table, which is the same table structure, but it's not memory optimized. It's just a disk-based structure. Okay. Do a select star from the table we recently created. And let's start with the natively compiled store procedures. So this is how it looks like. It says create procedure with native compilations schema binding, and then we have the atomic block, which is a set of options for the code that we're just going to do. And then inside of this, we're going to do an insert into this table, this set of information. So I'm going to create this natively compiled store procedure and execute and see what happens. It completed successfully. See, I'm not using anything that is very specific or special inside that code. Let's see another example. So I'm trying to create another natively compiled store procedure with schema binding. This time I'm trying to do a join. I'm joining my in-memory optimized table with my normal table. Let's see what happens inside this natively compiled store procedure. I get this error. It says it's not a memory optimized table. Normal table is not a memory optimized table and cannot be accessed from a natively compiled store procedure. This is one of the other restrictions that we have in SQL Server 2014. Let's say I'm again using a natively compiled store procedure, and I'm using an ABS and a power math function. Let's see what happens here. So I run this, and power was available, but what happened with ABS is not a supported natively compiled function. So basically, this is just a regular built-in function, but it's not working inside this type of store procedure. However, if I want to use all those options, I can still do it ad hoc, like we just saw. So I will try to do this select join an in-memory table with a normal table outside the natively compiled store procedure, just using an ad hoc query, and it works. In this case, it doesn't show any information because I don't have information in those tables, but it's not raising any error. And if I try to do this same select statements using mathematical functions, but using ad hoc queries, it is going to work. It's not showing me any error. So as you can see in SQL Server 2014, you have both options. Just use an ad hoc or natively compiled store procedure. It depends actually on what you need to use. I will try to create a trigger over this in-memory optimized table. And again, it says this is not a valid option. You're not able to create triggers over your in-memory tables. The same case for foreign keys. I'm going to try and create foreign keys for these tables, products and product sales. And again, we get these messages that is not supported for in-memory or memory optimized tables. So as you can see, those are the limitations in SQL Server 2014. So back to the slides. Let's jump into SQL Server 2016. So what's new on this version? Well, we have storage and memory algorithms improved. We have concurrency handling improved as well. There's a new garbage collector which is actually really good. We have more operators available inside the natively compiled store procedures, and now you are able to modify structures. Remember that if we missed the column name or we forgot to create our index, we needed to go back and delete our table and recreate it. Well, now some of those options are available, and we're going to see some examples about it. So we are going to name here as a few of improvements. Back then in SQL Server 2014, you used to have a maximum size of your in-memory table of 256 gigabytes. Now you can have a 2 terabytes table. ping into memory. And that's actually a lot of space. And of course, you need to make sure that your server does have the memory to support that, right? You're probably not going to be able to, store 2 terabytes of information if you have just, a small server with 8 gigs of RAM. Now, the collation of the string variables used to be a default called bin2. Now you can use any collation, but there will be a performance tree. So now you are able to use Japanese, Chinese collations, but if you choose to do so, you will experience a bit of a performance degradation. So when possible, still try to use the default, but if your business case scenario requires it, still go for whatever you need. Just do know that the performance is not going to be exactly the same. Then we have a structure modification available to drop, add column, alter, reveal indexes. Now we are able to do all that. We weren't able previously on 2014 to use any type of transparent data encryption. Now this is available for data on disk, basically. So this is actually a really cool feature in case you want to use sensitive data inside your in-memory tables and you have some type of audit restrictions. This is going to be actually very cool for you. And then we are now going to be able to have parallel plans for certain hash index operations. Remember that the hash index was an equality operator, mainly type of index, where you define your bucket count. Well, originally all of the plans were basically serial. Now you are able to have parallelism on those type of operations. This means that you are not able to add a little bit more to your performance tuning with these parallel plans. And then for the natively compiled store procedure, we also got a bunch of improvements. Now you are able to do left and right outer joins. Remember that doing a select distance wasn't possible. Well, now it is possible. You are able to use OR and NOT operators. You are able to use subqueries in all clauses of the select statement. You can even call another store procedure inside your store procedure, which is called a nested store procedure that wasn't available before. You are able to use the union and union all operators, and now all mathematical functions are available inside your natively compiled store procedures. So as you can see, a lot of limitations that we just saw and tested, they are just gone in 2016, and you are able to use this. And this is just actually some background information, but it's actually very cool. It says that the dependency on file stream processing has changed. So basically, when you create your memory optimized file groups, SQL Server will create a folder for you. And let me just show you this real quick. Database. As you can see, SQL Server already created a bunch of stuff over here. You see this file stream, HDR file, and then you see all these type of files and folders. Well, see, you need to perform operations of read and write over those files. Well, turns out that on SQL Server 2014, they use the file stream option that was already available. The file stream option that you use for storing, PDF files or images instead of storing inside a table. Well, they use the same technology to exchange information from the memory to the disk. Turns out this file streaming was not given the best performance possible for this type of operations. So in 2016, this file streaming processes from memory to those files that we just saw was replaced, and it is now doing a direct call to the API of NTFS file systems. Basically, it's now a much faster file processing. This means that information, transfer at a faster rate from memory to disk, and vice versa. So this is actually one of the improvements that's happening under the hood that is going to make in-memory tables much better, faster, and reliable. This is another under the hood feature, the log reader threads. In 2014, there was just one log reader thread per database to read transactions affecting memory optimized tables. So this means that every time you had an operation and this needed to interact with the transaction log, you only had one thread available, meaning some type of single point of failure or performance point. On 2016, now you have multiple log readers available, and these are going to be scalable by the number of cores. So SQL Server is going to be smart enough and know that you have, if you have a big server with a lot of CPU cores, then it is going to have more logs, and so the interaction with the transactional log is going to happen at a much faster rate, which is actually improving your performance as well. Back in 2014, when you were using always on, there was some type of delay. It was actually very small, but there was a delay when moving information of a memory optimized data from one principal to a secondary, or from a principal to a mirror, or whatever you want to call it. And now this has improved. The data will now be almost available immediately, and so this is actually an improvement related to always on when using in-memory tables. And then when deleting a huge number of rows, the version of row versions due to lots of changes in your table, well, back then the garbage collector used to have some type of delay as well. If you used to have a table in 2014 where you were doing a lot of insert, delete, update statements, then there were duplicated versions in memory. Then the garbage collector needed to, get these and delete them, and any outdated information, just remove it from memory. It was doing a good job, but now it's actually even better. The garbage collector improved, and now it is doing a much better job. There wasn't a scenario here where you had a big table. Let's say you are using some type of OLAP or data warehouse type of a scenario, and then you need to completely delete a table. So back then in 2014, there was a small delay to remove all that information from memory. Now it's much faster. So if you have a 200 gigabytes table pinged into memory and you delete, now you will get that memory back at a much faster rate, which is actually very good. And so, oops, let's see, 20. In action. And we are going to execute the same exercise. Probably, maybe. Let me just change the path of this database. Yes. And so I'm going to create, again, the in-memory table, the same one that we just been using, but this time on my SQL 2016. If I refresh over here my database list, you will see this already created. Now we are going to proceed in order to create, let's see, in this created. We just define this one called 2016 over here. And so I will define my in-memory file group inside my in-memory database. Let's see. All right. Okay, now I was able to create this in-memory file group, and now I will try to create my in-memory table on my 2016 version. So this time I will try to create an XML data type, and I'm going to create a Chinese type of column. I run this query, and it still says that XML is not supported with memory optimized tables. So this is something that haven't changed in 2016. We still have some restrictions. So I will just try to create my Chinese collation over that chart called. Let's see if now it works. See, now this time in 2016 I didn't have this problem. I can have my Chinese characters stored in this collation column, and it won't be a problem. Also, I forgot to create my indexes over here. And let's see, okay, this time I'm going to try and create them after the fact. So I'm going to add this non-cluster index over here. This time I was able to do it on 2016. And I'm going to create a hash index separately as well. And I was able to do it as well. So as you can see, those restrictions on 2014 now have changed. And now I have more room to play with, if you will. Let me just drop this table and recreate it so it is actually the same structure we used to have. I'm going to recreate those indexes. All right, now I'm going to create my normal table in 2016 so we can do all the testing. Okay, so I just query a memory table, and I'm going to try and do the natively compiled testing that we did last time. So I'm doing a join operation between a normal table and an in-memory table inside a natively compiled store procedure. Still fails, so as you can see, 2016 still has that type of restriction. I'm going to create these mathematical functions inside natively compiled store procedure and see what happens. And this time it completed successfully. It means that all the mathematical functions are now available in 2016, so that's no longer a restriction. And again, if I try to do the ad-hoc queries, again, it's still the same. I'm able to do this without any issue. I will try to create a trigger on that table and see what happens. And this time I was able to create a trigger. So on 2016 now we are able to do triggers, create triggers over memory optimized tables. And foreign keys, I'm going to create these tables and try to use foreign keys relations. And on 2016 now I was able to do it. So now I'm able to use foreign keys on this version. Remember that I was talking about the garbage collector improvement? Well, over here I have some type of performance. On my left side of the screen, I'm connected to my 2014 instance, which is my local instance. And what I'm going to do is that I'm going to run 100 iterations of insert statements. But as soon as I insert the information, I'm going to delete it. This means that this is going to happen over and over and over and over again, 100 times. Insert, delete, insert, delete, insert, delete. And what is going to happen is that, like we mentioned during the presentation, there are going to be duplicate set of information in memory. And then the garbage collector needs to grab that duplicated information or row versions and delete them. And I'm going to do this on 2014 and on 2016 and just see if there is a performance difference. So on the first one on my left side, I'm connected to 2014, and I'm going to run this now. So it took 1 second, 0.13 milliseconds. And then I'm going to do the same exercise. So I'm going to connect to my SQL 2016 instance and do the same exercise. I'm going to insert, delete, insert, delete, insert, delete a lot of times and see if there's any change on the behavior. As you can see, this is just my laptop and a single test. And even though this is just a small laptop with a small databases and just it's a simple example, you can see a difference of performance. 2016 does have an improvement on the garbage collector. If I insert and delete a lot of information and it creates those duplicate garbage in memory, it is going to delete it faster. And if actually delete it actually managed to delete that information faster, your queries are going to be much faster as well, because it's not going to wait for, you know, memory space that is probably not available anymore. So as you can see, 2016 does give you a performance boost just by installing it. You will have even a much better in-memory tables. And now some conclusions. Well, we can see that there are in-memory performance improvements in SQL Server 2016. We have less limitations, and I actually want to, this is very important, you know, the less limitation is not the same as non-limitation. So we still saw that the natively compiled stored procedures still have certain built-in functions limitations for strings, and certain operators are not there yet. You still can't, you know, join between normal and in-memory tables. But do know that Microsoft is working, you know, very much on this type of improvements. And as we continue to see service packs, and as we continue to see newer SQL Server versions, it's probably that you are going to have even more improvements on this type of topic. We saw that we actually have great algorithms and improved optimistic algorithm for concurrency, and also we saw that the garbage collector is actually very much better. And we actually saw that an improvement in the natively compiled stored procedures as well. Now we have less limitations, and the in-memory tables now you are able to also, you know, alter them. You are able to use, you know, certain data types that used to be restricted, and now this is going to be a much you know, user experience for a DBA or a developer. Back then in 2014, with so many restrictions, people used to ask me, well, you know what, this is very cool, but I don't know how I can make this fit in my environment because of all those restrictions. Well, now that we have less restrictions, it's going to be even easier to use this and implement. And that will be the presentation for today. On screen you will see my email, alejandro@sqlturbo.com, my Twitter information, LinkedIn, blog. In case you want to contact me, reach out to me. I will be happy to answer any question. Thank you very much for attending this great presentation today. Maybe any questions that you might have, you can post in there.
This is Jim here, so there's some here. Hang on.
Okay.
Oh, no, it's just a thank you from Radu.
Okay.
Okay. Thank you for attending, Radu. Really appreciate it. So that's all. Folks, if you guys have any questions, feel free to reach out to the IMVC team or reach out to Alejandro directly. You guys all have a great day.
All right. Thank you.
Thanks, everybody.